Hello everyone. In today's section, we are going to see about vascular grafts. What is vascular graft? It is a tubular implant used to replace, repair, and bypass the natural blood vessels when it is damaged. And its main function is to restore the normal blood flow. When the artery, veins, or natural blood vessel is blocked or some infection or damage means the blood flow is not normal, so there is a problem arises. That time the vascular graft is restore its normal blood flow function. First, we have to know what are the three types of blood vessels in the human body. The artery, vein, and capillaries are there. In that, mostly the arteries are having this issue regularly. And why we need the vascular graft? First one is blocked vessel. This is the condition where the fat is deposited in the artery, so the blood flow is stopped and damaged. So the condition is called atherosclerosis, and in that condition we have to bypass the arteries. And second one is damaged arteries, it is called aneurysm. In that the arteries are damaged due to some genetic or our normal life process. And second one is dialysis. For dialysis access we need to vascular grafts. And engineering challenges in vascular graft is first material selection. The material should be biocompatible and hemocompatibility because it interacts with the blood. It does not create any thrombosis formation in the blood. So we have to very confident in the material selection. And the natural graft is limited means we have to move with the vascular grafts. And the clinical complication is it is a high risk of infection and toxic and it when it is small diameter graft slow up for long term patency. Classification of vascular grafts. First one is autografts. It is from the patient's own vessels or replaced for the damaged tissues. Mostly the internal mammary artery is used to replace the damaged arteries, and it have a very excellent biocompatibility because it is a natural arteries, so it is very good for the patient. And second one is allograft. It is replace the donor vessels for the damaged tissues. For it is having the low biocompatibility because it have the from the outside body, so that sometimes it create the toxic reactions also. And third one is synthetic grafts. When we have to create a synthetic material like we have to choose a polymer materials, and we create these synthetic engineered materials like Dacron. And in this it is a different material, so it must be a biocompatible and hemocompatibility and good with the human body. So there are three different types of vascular grafts. To create a good and innovative vascular graft, we move to bioactive coatings. It develops the antithrombic surfaces. When the heparin and albumin is coated with the material, it should be a biocompatible material. It does not create any allergic reaction. And second one is porous scaffolds. The engine microporous structures that promote the endothelial cell infiltration and natural tissue regeneration. And sometimes hybrid designs, the natural with the synthetic grafts or textures also used. And we also used the 3D bioprinting to create a very good vascular graft. To make a vascular grafts, we use three different types of polymeric biomaterials, that is polytetrafluoroethylene and polyester. The polytetrafluoroethylene is of excellent flexibility and nick resistance. It is widely used in the peripheral bypass surgery. It have a good long-term patency rates, and it is used widely in the medium or small diameter arteries replacements. And next one is polyester. It have a high tensile strength and it prefer for the large diameter applications, and it is used in the aortic replacements. And third one is polyurethane. It have a superior elasticity matching arterial compliance, but it is under the research. To test and validation the vascular grafts, we go into the in vitro testing, animal studies, and clinical trials. In vitro testing, the vascular grafts are tested by the mechanical testing, thermogenicity, and assessing blood analog fluids. And animal studies means the preclinical evaluation in the animal models to access the biocompatibility and patency and healing responses. And some clinical trials also made to ensure the good vascular grafts. This is the summary of this today's section. First, the vascular graft. It is the purpose and function is it replace the diseased or damaged vessels and bypass the diseased vessels and repair the diseased vessels. And it has served to enhance the biocompatibility and hemocompatibility. We use heparin coatings and endothelial cell seeding, and it have the applications of coronary artery bypass and peripheral artery reconstruction and dialysis access. And it have advantages and limitations. Advantages: it is a life-saving and immediate restoration and establish the surgical techniques and protocols. The limitation is it is the synthetic graft infection. Sometimes it leading to the thrombosis formation, so the blood flow is clotted due to this also. And to made a per small diameter graft is very difficult and complex process. Future of vascular engineering is a bioengineered living grafts are may be made. It patient-derived stem cell differentiated into vascular tissue and natural growth, and it having the remodeling capacity. And the second one is smart antimicrobial surfaces. To enhance the surface modification, we have the good biocompatible and hemocompatible with the blood. So this smart antimicrobial surfaces prevent the infection and promote the healing also. This is the assessment to evaluate the understanding of the vascular grafts. These are the references. Thank you.